Okay, so let's get into chapter 2 and start talking about functions. And as you can see here, this is called functions in the real world. So what we're going to do is think about how some real world situations can be modeled mathematically. And actually that's what we'll be doing through the entire semester, but we're going to start off just talking about the basic idea of what a function is. Okay, so here we've got the definition, general definition of a function. A function f is a rule that assigns to each permissible value of the independent variable one and only one value of the dependent variable. So I am, as you can see here, stressing this one and only one value of the dependent variable idea. So I'm going to keep coming back to that. Less formally, each input to a function f gives one and only one output. All right, so this definition of a function, I think to really get an understanding of how it works, we need to think about some situations that maybe aren't functions and see exactly how they violate this rule about each input to a function gives one and only one output. So let me go over to my whiteboard and let's look at an example of something that is, well, let's do a couple. So here's something that is a function. Okay, so I'm going to pick some numbers over here. This is going to be what we call the domain, the set of inputs. And my function is going to go to the range, the set of outputs. Okay. And I put 3 elements in my domain. Let's actually say that they're numbers. These are going to be the numbers 1, 3, and -4. Okay. And over here, I want to have some other elements for my range. So there's another 1, and let's say 10 and 0. Okay. So let's say that 1 goes to 1, and let's say that 3 goes to 0, and let's also say that 4 goes to 0. So is this a function? Well, yes, this is a function. I guess I said it was already, but it is a function, yes. Okay. And the reason it is a function is because each input goes to a single output. So you might wonder, okay, well, what about 1? Well, it goes to another it looks like it goes to itself. That's fine. 3 and 4 both go to the same number, but that's okay because if you look at this definition, it says each input needs to go to one output. So we're not violating anything with this arrangement. Okay, so this is fine. All right, let's look at another one. And I'll tell you ahead of time, this is not a function, what I'm about to do. So imagine that we have another set over here, and let's say that I have the elements 1, 3, and 6. And over here I've got the elements 2 and 5. And let's say that 1 goes to 2. And let's say that 3 goes to 5. But let's say that 3 also goes to 2. And then we can say that 6 goes to 5. Okay. So this is not a function, what we're looking at. this is what we call a relation. So specifically, why is this not a function? It's not a function because of this. Let's clearly identify the problem here. Because 3 goes to 2 and 3 goes to 5. So we have an input that doesn't have a unique output. So we have an input with 2 outputs. That can't happen with a function. Okay, so that's the problem. All right, so hopefully that kind of makes a bit clear where this definition is coming from when it says each input to a function gives one and only one output. Now, I already defined domain and range sort of loosely, but here's the official definitions. The domain of f is a set of all independent variable values or inputs, and the range of f being the function, is the set of all dependent values or outputs. Now, how do we write functions? How does the function notation work? Well, the standard notation is written right here. Now, another thing I should mention is that in this class, although x is a very common independent variable, we very often will use t as the independent variable. So it's very likely that you'll see a function written like so, y equals f of t, or it doesn't have to be f, it could be g or h or anything else. So here's a very common one, h of t. And this is function notation. So the way you read this is f of x or f of t or h of t. F is the name of the function. In this case, h is the name of the function. And then we have the independent variable and we have the dependent variable. So the independent is the input and the dependent is the output. All right, so it's really important in this class that you be able to take a paragraph of that explains a function and turn that into an actual mathematical function. And in order to do that, you've got to understand the way that we write functions in words. And so this is the key sentence here. Blank is a function of blank. So this is typically how we write functions if we're writing a sentence. So I might say, for example, height is a function of time. Say, for example, if you're jumping up in the air and then you measure your height at any given time, you would say height is a function of time. And so time would be the input and height would be the output. And so I could write that as h of t. So time would be here. That's the independent variable, and height is here, the dependent variable. So that's just an example. But the thing to take away from this is whenever you see a function written in words like this and you need to turn it into math, you've got to identify what's the input and what's the output. That's very important. And so the thing that comes last is the input, and the thing that comes first is the output. So output is a function of input. So always think of it like that. All right. Now, we're going to be looking at different representations of functions. And the 3 principal representations are right here. We've got a table, we've got a graph, and we have a formula. So we're going to look at all 3 of these. And a 4th method would be down here. Just functions can also be described in words. So that's something that we'll see a lot too. Okay. How about an example? So here is a table, right? So if this is a function, it's going to be defined tabularly, right? And the question is is d a function of n? So this is saying, is d, whatever d is, it's going to be, since it's coming first, that's going to be the output. So n will be the input. Now, what do d and n stand for? Well, let's read the rest of the slide. So the following table summarizes the results of a game in which a 6-sided die is rolled a total of 6 times. So n is the number of dots showing up when you roll the die. Oh, I'm sorry. I just said I was reading one thing and saying another. N is the roll number, so it's whether it's the first, second, third, fourth, fifth, sixth time that you rolled the die. D, on the other hand, is the number of dots. Okay. So in order for D to be a function of n, what we need to happen is that we can't ever have an n going to more than one d. So we can't have like 1 going to 2 and 1 going to 3 or something like that. So that would be bad, right? So put an X through that. But that doesn't happen here. We have 1 goes to 3, 2 goes to 2, 3 goes to 4, 4 goes to 3, 5 goes to 6, 6 goes to 2. And these arrows are indicating the kind of direction of the function. So this is okay. Yes. Each input has a unique output, so this is a function. All right. Furthermore, let's look at some questions about this. Let's find the domain of this function and the range of the function. Let's evaluate the function at a given input. And then part D here, let's find the values of n for which the function equals 2. Okay, so that's quite a bit to do. So let's dive in. First, finding the domain. So the domain of this function, that's the set of inputs. And it's easy enough for me to circle them. This is them right here. That's going to be my domain. Okay. But the important thing here is that you write this correctly. So I'm actually going to go to the whiteboard and talk about how you write a set of the form 1, 2, 3, 4, 5, 6. Okay. So on a number line, this is, so actually what we're talking about for a moment here is going to be interval notation. So just some interval notation issues. This is the set 1, 2, 3, 4, 5, 6. And it's not including the numbers in between. So like 1.5 is not in here, 2.5 is not in here. And so it's just the discrete values 1, 2, 3, 4, 5, 6. So here's the proper way to write this. You actually have to write them all out, and we use curly brackets. Okay, so when you have discrete points like this, this is the way to do it. Now, just for contrast, if you wanted to write down the set 1 to 6, and you wanted to put everything in between there, so like 1.5, 2.3, everything, then that would be written as follows. Square brackets 1 through 6. Okay, so square brackets include the endpoints, and they also get everything in between these two numbers. And let me give you one more example. Here's a third one. If I want to get everything between 1 and 6, but I don't want the endpoints, okay, so I want to leave out 1 and 6, then I use parentheses. Okay, and so this is called an open interval, and this is a closed interval. So you need to be comfortable using this kind of notation. All right, so let's get back to our problem. So that's the answer. That's the domain, by the way.